and we have default, right? Among which the most important one is the dynamic routing, right? So let's come one by one. What is static routing? Static routing is nothing but we are routing the packets, or we are configuring the routers, right, manually. We are configuring the routers manually and informing the router that the next hop for this router is this particular router. So let's assume there are some four routers in this network, right? So how do these routers know that this particular interface here? So let me first brief you out in this network topology what all things you must be aware of. One thing is that this particular portion, if you see here, this particular portion is called as an interface. So when a router is connected to a cable or a wire, this has an interface here, and it depends on what type of Ethernet cable are you using. If you are using a fast Ethernet cable, then it will be FA0/1. That depends on the device, right? If you are connecting to the same router towards this side, this interface is different again. This interface is different. So this is FA0-0/1. This could be FA0/2, right? Similarly, for the other portion of the router, if you see, it could be FA0/1 for this router this side, and for this side it would be FA0/2, right? Similarly, and so forth, the things go on like that. So you must be aware that each interface where the cable is connected, that is called an interface, and it has its own name, or it has its own numbering. And why is it important? The reason why it is important is, when I tell you that we are configuring a router, right? So what we are doing there is we are going to log into the router, right? We are going to open the command line interface. We are going to type the commands there, right? You will be typing the commands in such a way that, for example, if you want to assign a IP to this particular interface, you will be typing the command and you will mention the interface there as FA0/1. The IP address will be 192.168.0.1/24. So you are telling that this interface here, FA0/1, is having this particular IP address and its default gateway, and the default gateway of this particular IP address is 192.168.0/2. So that's the default gateway. Now, what do I mean by default gateway? Default gateway for an IP, if you are giving an IP and you are providing a default gateway for that IP, the router makes a note of that, mentioning in its routing table like this. It makes a note and mentions that this particular interface, FA0/1, right, FA0/1 has this particular IP address assigned 192.168.0.1, right? And the subnet mask is 24. Its default gateway is 192.168.0.2, right? So the major advantage of a default gateway is, if any packet is egressing out of this particular IP address, if for example you are trying to send some IP packet, let's say you are trying to ping, you are sending a ping response to some other IP address within the network. Let's assume you are sending a ping response to 0.3, right? 192.168.0.3. Then what will happen is, after this, it will first go through the default gateway, right? So it will first go through the default gateway, and from there it will see where it has to go according to the routing protocol, whatever we have configured, right? So default gateway is a must in any network, whether it's your home network, whether it's your device, your laptop, your mobile phone, anything. It will have a default gateway in it. So always you will be seeing this when you go to the IP address. I think I'll just show you that, just a second. Okay. Okay, so if you see here, this is my network interface card details, right? I am currently connected on this particular cable here, Ethernet connection, right? So I am directly connected via the cable. I am not using my Wi-Fi. Okay, and the IPv4 address which is assigned to me, if you see here, it's IPv4, and it says that this is what is my IP. And what's my subnet mask? We have denoted this IP address /24. And how am I telling that? Because I can see for the initial octet, 255 is completely occupied. What does this 255 indicate? That this is the network portion of the IP. This 255 indicates that this is the network portion of the IP. This 255 indicates that 0 also is the network portion of the IP. Then what is usable? Usable is the 0. So that means 116 is the host, right? And what is the network? 192.168.0.0 is the network, right? So anything from here to until 254 is the IP address which will come in between this. The reason being 255, 255, 255, this is occupied, this is occupied, this is also occupied. The only thing what is usable in within my network is from 1 to 254, right? 0 is the network IP. Now, if you see, I am using this particular IP address for communication purposes, for going to internet and all. Now, if you see here, the IPv4 default gateway. So I have shown you this earlier as well, but since we have come a little bit further, you will understand things now. So if you see the default gateway here, this means that initially, if any traffic is originating from this IP, it will go to the default gateway first. So that's the first hop for the this particular IP, right? And after that, it will go accordingly where it has to go. It will go to your ISP, and then it will go to the destination. Simple, right? But how does the device know? So it basically knows that based on the routing information what it has within its network interface card. Let me show you how my route looks like. Okay, so how do I show this? I'll show you the IPv4 table, route table, what I have in my device. Based on that, you will get a basic understanding. So if you see this, if you see the route table, this is how it actually looks like. So this is where you will be troubleshooting in future as well, right? So now, if you see here, what does it show? This is the IPv4 route table. And how do you fetch this when you are using a Windows machine? You just type the command open cmd, right? And then go to, and then type route print. Simple. Once you type this and hit enter, you will get this on your machine. If you people are connected using laptop, then you can try this right now. Open command prompt, and I believe everybody knows how to open command prompt, right? You just have to go to your start, search for cmd, that's it, right? Once you do that, type route print there, right? Everything in small letters, and hit enter. You will get routing table there. You will get routing table for IPv4, and also you will get it for IPv6, right? I am just showing it for IPv4 because I am predominantly in IPv4 network only, right? So let me explain you how to read this whole thing. And based on that, this is the same thing what a router also stores inside that. So a router will always be storing this particular information, right? So now If you see here, the network destination, that means it is 0.0.0.0. What does this mean? And it has the network mask as 0.0.0.0. What does this indicate? This indicates that any IP address. Remember, I told you in the beginning that the class A IP address 0.0.0.0 and the 127 should not be calculated within that. The reason being 0.0.0.0 is a default IP, right? And this particular default IP, if it is there within your route table, this indicates that any traffic, literally any traffic, apart from whatever we see here within the destinations, apart from all these other IPs which are indicated below, apart from these IPs, if there is any other IP coming into the picture, so let's say my device here is having 192.168.0.116, right? And I want to send a packet to 192.168.0.117. Now you tell me, if this particular is my destination, based on which particular route will the packets be routed? So if you go, so your system does this internally once you type this. So if you see this, there is no 117, there is no 117, 111, nothing. There is nowhere 117, right? So now it will see that, okay, there is a default route which mentions that I have to take this particular subnet mask and the network destination, and the default gateway where the packet should actually be routed to is this 192.168.0.1, and that is why it is important, right? Then the destination wherever you are going via this interface, from this interface I am sending a packet towards 117. So this interface does not know where is 117, but this default gateway would know that, right? So the packets will first go to 0.1 for sure, right? And that is how you are going to replicate it also in future. Also, if you're going to troubleshoot some things, you're going to do it in a similar fashion, right? So if you see here, this particular interface will first send the packets here, right? And now after it sends the packet here, according to the routing protocol or according to the routes this particular destination knows, based on that the packets will be routed. Now if I explain you in a real world scenario where I am currently, this particular IP is my device IP, right? So that's a check mark. Now I want to send the packets for 117. I don't know 117 if it is assigned to someone or not, right? So let's assume that 117 is my mobile phone. Okay. Now if I want to reach this particular 117, first the packets has to go to the default gateway. Now who is this default gateway? If I tell you, this default gateway is my router, and for you also it will be the same, right? It could be 0.1 or it could be some other IP address, that depends. So this is my router IP address. So first I'm sending my packets to router, and now router, it has its own table like this. So within router, it will definitely have a routing information for 117 if there exists one. So let's assume it exists, right? So if it exists, then 117 will be shown as some or the other IP address there. So based on which interface it should go out. So the reason why I introduce interfaces is this. If you see here interface, right, what does this indicate? This indicates from which interface the packet has to get out. So in my device, I only have one interface for the Ethernet cable, and which is having this particular IP address, and that is the reason why it is showing me this IP, right? And then we also have this particular interface with 91.1. We also have an interface with 211.1, and we also have an interface, I think only those. We have three interfaces, like my device has three interfaces with these IPs. So that means I really have more two adapters, right? I have a Wi-Fi adapter also. I have a Wi-Fi adapter also. I have a virtual machine adapter also, right? All of those has their own IP addresses, and there is no clash. There will never be a clash. And I believe by now you should understand how there is no clash. There is no clash because we have ARP in the network. What does ARP do? It also checks if there is any sort of clashing between the IP addresses, right? So that is there. Now we have additional column here which tells that what is a metric. So the reason for this metric is to inform the router or the device or the network interface card that this is the most preferable route. Yesterday I told you that in networking least number is what is the preferable one, right? So if you see the whole entire IP route table here, what's the least number here? The least number is 35, which indicates that your system should prefer this particular interface to get out of the network, right? If it falls within this particular bracket, that is 0.0.0, that means it is not matching any of these. If it is not matching any of this, it should go via this interface because the metric is the least. Right now, let me give you an example. There is another route which is having 0.0.0, 0.0.0, and the gateway is also same, but the interface is different, but its metric is 25. Right? So what your device does is it checks, okay, metric is lesser and the destination is this. So let me route the packets using the other interface that is not this, because this metric is 35, that metric will be 30, that one metric is 25. So that is lesser, right? The less the metric, the higher the preferable the route. And remember this rule. The lesser the values of metric, the higher the preferable route. That's it. So now, based on this, right? So now, based on this, the same thing goes on with the routers as well. Okay. So now, if you see, we were at the portion where we were discussing static routing. Okay. So what is static routing? Static routing is nothing but an network administrator, right, or you yourself is going to configure the router and tell the router that the next hop for you should be so and so, that the next hop for you should be dot 192, 192.168.0.192, right? And this side for this interface, your next hop should be dot 180. So on and so forth, you will be configuring the same thing for this interface also, right? So that is static. So manually, if an admin intervenes in order to let the router know what's your next hop and all, protocol, the same protocol should be there on the routers. So let me give you a short example. Now, let's assume that this router speaks, right? So you tell me, how will they exchange information in Hindi? So that's a big challenge, and that is the reason why specific routing protocol and assigning the interface with the IPs. That's it, what the network admins do. Nothing complex, right? So on a router, what they generally do is they log into it, they go into the configuration terminal mode, and once they get into the configuration terminal mode, they start configuring the IP addresses for interface, right? And then later they configure the routing protocols. Okay. So there are different routing protocols in dynamic. I'll come back to that shortly. Next, we'll discuss about default. Right? Default is nothing but what we have seen here, 0.0.0.0. and the net mask is also 0.0.0.0, right? There is no major importance of default routing, but it comes in handy when you are trying to configure a network within an organization. So let's assume that this router is sitting within your office network, right? There is another router which is sitting outside your office network, and there is a firewall here. These all are connected. Now, you don't know the address of this and address of this, but still you want the packets to reach this particular destination. How will you do that? What you will do is you will be sending the packets to 0.0.0.0. Simple. Once you mention this particular IP address, the router will know, okay, they are telling that go anywhere. There is no specific destination. So what will happen? The routing table will see that the next hop for me is the default gateway, which is the firewall. And for firewall, 0.0.0 will be, it will reach firewall, right? Once it reaches the firewall, firewall will see who sent the traffic. So this particular router will obviously have an IP address and a MAC address, and whatever content it is trying to request from the external router or external destination, that it will try to fetch for this particular internal router, right? So that's the only advantage of default. Okay, now another thing we have already learned regarding this, but still we'll discuss another time. So we see here 127.0.0.1, and these are the loopback addresses. What's the use of this loopback address? The reason why loopback address is there for each and every network interface card is testing for testing the network interface card. That's the major thing what we use. Also, loopback addresses can be used by different applications like the VPN service providers, right? In order to get an IP address assigned over a specific port, over a random port, right? Over a random TCP port. Okay. Now, what we'll discuss is we will be discussing regarding the routing protocols, the dynamic routing protocols, and before that, I will introduce you the concept of administrative distance. Right. Now, what is an administrative distance in a router? It is nothing different than what we have seen for metric, right? But administrative distance is relevant to the routing protocols and was introduced by the Cisco. Now, what is an administrative distance, right? So basically, let's assume that this is a router, this is another router, this is the device. Okay, this particular router is connected to its own connectivity center everywhere within the cloud, and this particular router is connected to its own connectivity center within the cloud, right? Now, this router is using RIP, right? Don't be worried about this, we'll come back to this. So RIP is a routing protocol, right? And this router is using OSPF, open shortest path.
platform.
Exactly. And this is routing information protocol. Okay. Now, how will this particular router decide whether the packet should be routed through this interface or whether it should go through this interface? because here the routing protocol is configured as RIP, but here the routing protocol is configured as OSPF. Now, how will this device understand whether it has to go via this or whether this? That is the main advantage of administrative distance. So each and every routing protocol has its own administrative distance, right? So if you see, for routing information protocol, the administrative distance is 120 and OSPF it is 110. And what have we learned earlier? The lesser the value, the higher the preferable the route, right? So in this scenario, the router will not do any sort of decision. It will simply see that OSPF has the AD of 110, hence the packets will route like this. It will not choose this path, it will choose this path. The reason you have configured OSPF on this particular interface, right? So this is how, and the major advantage of an administrative distances, right? You need not remember this values. However, for RIP and OSPF, you can remember the values as this 120 and 110. These are some things which in general the organizations configure. Right, and the major ISP services which we see, uh, like Act Corp, Act FiberNet, BSNL, they use EGP, BGP, and EIGRP. Right, so external border gateway protocol, right? Enhanced interior gateway routing protocol, right? This is the administrative distance for EIGRP, and this is the administrative distance for EBGP. Right? No need to remember, not a problem. But what you can remember is 110 and 120. Right? Now, the major important question what people ask in an interview is, what is the administrative distance of this? What is the administrative distance of the interface to which the wire is connected? What is it? It is 0. The reason being, that's the initial hop. There is nothing to decide there, whether it has to go here or here. First thing and foremost thing is it's 0 for the interface itself, and then later it will see which particular routing protocol is there. So accordingly, it will route the packets. Right? And now, what is the administrative distance of the static routing protocols? The static routing, what we have configured, there is no protocol in that. What is the AD of static routing? It is 1. So what you have to remember is, for static it is 1, for the connected interfaces it is 0, for RIP it is 120, for OSPF it is 110. Some basic things which should be remembered, right? You can remember this as well, but not very much important, right? Okay, now what are the types of dynamic routing protocol? We have just seen 4 routing protocols, the dynamic routing protocols. One among which is RIP, which has version 1 and version 2, right? Next is OSPF, right? Then what is next? EIGRP, right? EBGP, sorry, EBGP, right? IGRP, Okay, and also we can make a note of external gateway protocol. Right, so we will see and discuss about RIP and OSPF. These are not much important, but they will be used by the organizations. But what is interview specific or what is required is these two. So the basic thing what you must understand always is regarding routing, these three are to be understood in a proper fashion. What is static, what is dynamic, and what is default. And all of the routing protocols what we are discussing, they come under dynamic. They do not come under static or default. That's the basic thing. That is where people will confuse you. Okay. Now, now let's discuss about RIP. Right. So in routing information protocol, which is actually configured in a smaller organization, not a bigger organization, because it has two versions, right? Two versions are there. What does the version 1 and version 2, what's the difference between that? So version 1 generally supports classful IP routing. What is classful? Classful IP routing is nothing but utilizing the entire IP range. Let's say you are a very big organization and you have adopted class A. So you are thinking that let me use class A IP addressing within my organization and you want to configure routers with RIP, right? So if you use RIP version 1, what happens is it is not going to ask you for subnets. So you cannot configure subnets. It's going to use classful IPs. Classful IPs is nothing but from uh, 1.0.0.0 to 126.0.0.0. This whole network, these all network within class A, you will be using one by one, right? So for example, if you want to configure a router, you will be configuring it as 1.0.0.1, and the next router you will be configuring as 1.0.0.2. So you are not doing any subnetting, right? And also when you configure the RIP version 1 for a router, what you will be doing is you will be not mentioning the subnet mask. But whereas in version 2, it gives you the advantage of classless IP routing or CIDR range, classless interdomain routing. And this is what we have learned in subnetting, right? So that's the major difference between this version 1 and version 2. Right now, something else apart from version 1 and version 2 in RIP, specific to RIP, we have some important points. Right, so it is a distance vector protocol. Right, and its metric is based on what? Its metric is based on hop count. Okay, and maximum it can support 15 hops. Okay, so these are three important points related to RIP, and this is related to the version differences. Right. Now here I have mentioned it is a distance vector routing protocol. It is dependent on the distance vector protocol. What does that mean? Right. So what does this mean is that Let's take one router here, right? And let's take another router here. Okay, and let's take this one here. Okay, now if you see, if you see this particular router, these all routers are configured with RIP, right? RIP is what they have been configured with, so they understand the language. They know what protocols are supposed to be used and how to route the packets. Everything is fine. But in distance vector protocol, what happens is each router only knows about its neighboring routers. They do not know about the other all the other routers within the network to whichever it is connected. So for this router, the maximum it will understand or the maximum it will know is that okay, I have 0.1 as IP, 0.2 is my neighbor, and 0.3 is my neighbor, and that's the end of story for this router. For this router also the same thing. 0.3 thinks that okay, there is only 0.1, 0.2 and 0.4 within the network, nothing else. That's the end of the story for this router. Similarly for this guy also. He only knows 0.1 and 0.4. He doesn't know this 0.3 exists and 0.2 exists. So that is distance vector protocol. I hope you understood this. Only the neighboring router is what the RIP protocol has. So the information this router will have is only for this and this. It will not have the routing information for other things, right? I think while explaining this, I missed this point. So for this router, even 0.5, 0.3 and 0.2 will be known because they are connected directly. Okay, is that clear? Hello?
Yeah, pardon. As you said, RIP 120. Here you are saying like 15 hops maximum it can support. So I have doubt on that. Can you please explain that? You know,
Okay,
120.
so
Yeah.
yeah, right. So administrative distance is not related to the hop counts.
Okay. Okay. Got it.
Okay,
Yeah.
administrative distance is something which is given to that particular protocol as a numbering by Cisco. So that is how they have designed it. So because all of these protocols are nothing but Cisco's own thing, so they have developed this. We are just trying to learn the language of each and every protocol. That's it. So now, if you see static, how will the router know? Because we as a humans, we know that okay, I am configuring static, I am doing this and that. But how will the router know whether it was a static protocol which is configured here, whether it's a RIP protocol or whether it is OSPF? Because the routers and the computers don't understand uh, alphabets. They understand ones and zeros. So this 120 will be converted into a binary, and that binary is what the router will understand, right? The 110 also will be converted into binary, and that's how the router will understand, okay, this is OSPF, like that. Okay, so now,
Got it.
right. So now, its metric is based on hop count. That's easier to understand. But what is the maximum it can support? 15 hops. So within a network, if there are more than 15 hops, let's assume that I am sending a packet from this 0.1 router to some 0.16 router. It will not reach. The reason being that packet will die at the 15th hop because that's the TTL value for that according to the router information protocol. So that packet will be immediately dropped on the 15th hop. That's it. It will not be forwarded ahead. And that is why other protocols were introduced, that is OSP. Okay. Now, what else are we missing? Right. Another point in RIP is that every 30 seconds Every 30 seconds, the routers updates in its own information. So it looks for information. It tries to update it. For example, now it updated the information and it is aware that 0.2, 0.5 and 0.3 is my neighbor. For next 30 seconds, it will not look for any additional information, right? The moment this IP address changes, 0.6, let's assume. After those 30 seconds, it will obviously receive some or the other packet because ARP and all are actually going on. ARP will never stop, right? The moment this IP address changes, the ARP request, reply, duplication of IPs and all, everything will be checked. So at that moment, this router will update its information. Those 30 seconds have been lapsed. So that is what is about RIP. Nothing much is to be learned about that. The next thing what you can most probably do is we'll have to configure that on a router and check whether the packets are routing or not, right? That we can do on GNS3 or Cisco Packet Tracer,
Web address.
right? You will find n number of videos online, right? You can go ahead today, you can type in RIP version 1, RIP version 2, routing on a GNS3 or packet tracer, look for a video, they will configure it. You will get to know what are the commands they are using. They will be typing show IP into brief. They will be checking what IPs are there, how the protocols are being recognized. You will see the administrative distance value also there. Let me just show you that. Okay, so let me show you the classful configuration first. I think I have one with me. Let me just open that. Router 1, router 2. Okay, let me take this image. Okay, this is something that I had configured earlier, but I don't have the lab now. Let me just open up this just a minute. Okay, so when you set up a lab, right, within GNS or on Cisco Packet Tracer, you'll have to take one router which looks like this. Then you will be connecting them with the cables, and each and everything will have its own interface here, right? So once you connect this, so you can see here there are switches in this. So we are connecting this device to a switch, and the switch is connected to the router, right? Here we have a server which is connected to the switch, and the same is connected to the router. These all are in RIP protocol, and if you see the IP addresses here, 192.168.10.0.2, and this whole segment, this whole is in within one network only. The moment this interface changes here, it is within 10.0.0.1. Until here, it is within that particular subnet, and then the subnet changes here, 20.0.0.1, and it changes here, right? So now, because there are different subnets, different networks on different interfaces, that's the reason why we are introducing routing. So that routing protocol enables us to create a route between these different subnets. So here the subnet is, let's take this. So here if you see, this particular thing is in 192.168.0. Not 0, sorry, 10.192.68.10.0 network, right? So that's the network this particular subnet is in. This particular subnet is in another network, that is 10.0.0.0. This particular subnet is in another network now, 20.0.0.0. Right? This subnet is in with another network. This is completely in 180.10.1.0. Right? Here we have a class B subnet, that is 172.16.0.0. So that is how this was this basic lab atmosphere which I had. Right? If you see here, I have configured this particular network. So class C is there, class B is there, we have the class A's, right? So now once we have different subnets, we are configuring the routers with the required configuration. So this was an RIP lab, and I had configured all of these three routers at the top with the RIP. Right? I think which particular? I think this particular command output is for this particular router here. And if I show you how it looks like, so basically once you log into the router, what you generally do is you go into the once you open the router, because I had already configured it, I am looking for show IP protocol command. If you see this here, show IP protocol command, right? What information is it showing me? You see that it shows me that the routing protocol is RIP. And as I earlier told you that the updates will be sent or the updates will be received within 30 seconds, that is what is happening here. Sending updates every 30 seconds, next due in 4 seconds. So I think I have taken the screenshot when, or maybe I have looked for the command when it was 26 second, right? So now there is all the other information here, right? And now what else do we have here? I think how much packets we have sent and how much we have received is what we are seeing here. And this is the interface details. So if you see here, I have used serial cable here, and I have used gigabit cable here. And that is why it is showing accordingly, and their numberings as well. Based on this numbering only, you will be configuring the IP address. So you will type in the network as configure network, right? And you will give the IP interface name you will give SE 0/3/0, and then you will give the IP address there, because this is, I believe this was version 2 or version 1. Yeah, this was version 1 is what I, no, this is version 2, because we see subnets here. So because this is version 2, we are seeing subnets here. If it would have been version 1, you will not see subnets, you will see direct IPs, no subnets, right? So there you will be configuring the IP address. So in our scenario, you will be configuring the IP address like this: 20.0.0.0. I mean 1 slash whatever subnet we have got for that IP. So 8. Right. So this is how on a router you will be seeing the things. Right. Now, if you see the routing information source here, the gateway is 20.0.0.1 and the administrative distance. This distance is nothing like the hops it has to go. This is something which is relevant to that particular protocol, right? So that is there. Now, a few commands, just make a note of this so that you are a little bit handy. And also you can check out some YouTube videos for configuring RIP version 1 and version 2. So show IP int is nothing but interface. Let me just completely write it. IP interface brief, right? But when we actually configure it, you just write everything in short forms. Like I was trying to type show IP, so automatically the console takes the next thing, that is protocol. It automatically takes it, but here it did not, because it did not recognize. It could be that after show IP there can be something else also which can come in. So what we generally do is when you configure a router, it's little bit fast. So you will be like sh IP in BR. That's it. You hit enter. Automatically it will go to the show IP in brief. What does this command do? Right. This command will display. It will display IP information on the interface, right? So that's what it is going to do. Similarly, for show IP interface brief, you notice this point here that I am telling show IP interface, right? So I'll first log into that interface. First you open router, you will get into the router, and then you will go to configuration command, and then you will look into this show IP interface brief. So for all the interfaces, you will get the brief, right? For the on this router, you will get for this interface what's the IP and what's the subnet you have configured. For this interface, what you have configured. That is how you troubleshoot a network, right? In a network, sometimes what happens that once the deployment is done, once the deployment team has completed everything, sometimes what happens, some or the other engineer messes up with the subnetting configuration within an organization. What happens then? Then the engineers, the TAC engineers who actually troubleshoot the things, they start from the beginning. They check the ping. So I'll just show you how troubleshooting actually happens. Let's assume that I messed up the configuration here. Now, what the engineers will do is they will first see that this PC is not able to reach internet. Now, your job is to find out why. What will you do? You will start sending the reachability test towards the default gateway, that is the router, right? Once it reaches the default gateway, you see that okay, this link is fine. Now, what you will do? You will try to send the packets to this router, and when you're trying this, it is dropped. The reason being this subnet configuration I have messed up, right? So now the TAC engineer is aware some issue is here only, right? To make sure that the issue is only here, he'll try to ping from here to here and here to here. Everything is fine. He'll try to ping it here. He will not be able to reach. Now what will he do? He has proper guarantee that there is some issue here or it could be an issue here. Now he logs into this router. And then what they do, they open their network topology diagram, which the organization during the deployment time had provided. So that topology diagram will have each and every router diagram, switch diagram, and also the interface with the subnet and the IP, right? Based on that, they will verify. And how will they verify that? They are not going to configure anything. They are going to type this command, simple command, show IP in brief. That's it. Once they type this command, they get everything. So if you see here for this routing protocol, so I have shown show IP protocol. So for that particular protocol, what are the IPs I have configured? They will check everything one by one. That's it. They are not going to do anything apart from this. So it is that you are just trying to find out mistakes from what has happened in the past. That's it. Right. So the next command would be show IP route, then show IP protocol. Right. Show IP protocol is something which you are currently looking at. And then show IP route is nothing but you will be looking at the route for that particular IPs on that interface. So it will show that. Let me just show you a small screenshot of that as well. It will show you the connect, right? I think so. I have something from. Okay, let me show you this. Okay, so if you see this, so they have executed the command show IP route. Then you can see the codes here, right? The use of code will be when you see it here, right? So when you type show IP route on the console, on the router, what happens is you will get an output like this. Now, if you see the output like this, you can see it is C, it is L, it is D, 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 it is C, L, D. What does this C, L, D and all mean? It is nothing but this. L means it is locally connected, C means it is connected, right? And where is D? D is EIGRP. So they have configured EIGRP protocols for these subnets for 1, 2, 3, 1. This one, 4. This for these 4 subnets, they have configured EIGRP. Now, if you see this, you can see this IP or this subnet, whatever IPs come under this subnet shall go via 90.0.0.2. Right, and it is connected on what? It is connected on this serial cable, this serial cable, this serial cable, right? So they have made some routing on that router. Okay. So that is how you basically troubleshoot. The major important thing is to remember this particular thing. This is what shows whether you have actually have some hands-on experience on the um, router management and all of that, right? So what you can do today is, since you have learned about RIP, what you can do is go on YouTube, right? Search for the routing protocol, right? RIP, and look out for few videos where they configure it. They will create their own atmosphere and they will configure it, right? And see what they are doing. What are the commands they are inputting? When are they hitting enter? What are they doing? What's happening? Make a note of it. Take screenshots. Try to understand things. Just be like you have done that, right? You can also practice it. This is not a big deal. You can download the applications.
Cisco packet tracer,
Exactly, yeah. You can download Cisco Packet Tracer. You can download GNS3. I
GNS3.
would prefer GNS3, right? It's little bit simple and it's little bit easier to configure also. So you can download GNS3, right? Look out for tutorial videos online and practice.
Sure,
That will give you hands-on. Nothing else will give you hands-on. No matter how much I tell here in the session, I can give you brief information. Practicing is something which you have to do, right? So this applications, GNS3 and Cisco Packet Tracer, what they generally do is they give you, a very wide view within the network. Basically what you can do in this particular topology also is you can run a packet capture on this router, and then you can turn on this particular PC. So this particular virtual machine, whatever you will be configuring, from that you can initiate some traffic, like you can change its IP address. You can maybe see the DHCP messages flowing here and there, right, from this router to this particular device, from this device to this. So you can see the DORA process. You can literally see everything when you try and you have hands on that particular thing. All right. So now, so we have discussed about RIP protocol. Now what we'll do is we will also discuss a little bit about OSPF, right? So what's the major thing about OSPF? It's administrative distance. I earlier told you is 110. That's one thing. The next thing is that it's a link state protocol, right? We'll come back to that point shortly. What's a link state protocol and what's distance vector protocol is what you have learned just now, right? It is limited. So only the adjacent router's information is with this router. But link state protocol is not like that. It is that this particular router will know about every router in the network. That is how it works. So that is link state protocol. Right. So now what is the, what's the metric here in OSPF? By metric, do not get confused. I do not mean administrative distance. Metric means based on that particular parameter, the packets will be sent within the network. So here for RIP it is hop count. So only 15 hops is what it supports. But in OSPF, the metric is cost. What does cost mean? Cost is nothing but the value given to the route, like this. Right? The least the cost, the higher the preferable the route. Right? The another important thing about OSPF, what you should know is that there is something called as area zero, which is nothing but the backbone. Please make a note of this: backbone of the entire network config, right? And the reason why it is used is it is used in a larger organization. Admins don't want to keep themselves short-handed with RIP because RIP only supports 15 hops. But what if your organization is big, very large? They can configure OSPF. right? Now, it is also classless. It is also classless, right? That is what it means is it is used with wildcard mask. So when you're configuring the OSPF within the router, so you will be using a wildcard mask for sure, right? So what is a wildcard mask? Let me show you. So let's assume that 255.0.0.0. What is this? This is the subnet mask for what? Class A IP address, right? What's the wildcard mask for this? Reverse it. 0.255.255.255. This is the wildcard mask for the class A IP address. So let's assume that you have this particular IP 20.0.0.2/8 as an IP address given, and you want to configure OSPF on this router. When you will be configuring the routing protocol, that is OSPF, right? When you will be configuring configure protocol and all, you will be configuring for OSPF. You have to give the wildcard mask, not the subnet mask, and that is how it understands that okay, this one is a class A IP. What about class B then? Reverse it again. It will be 0.0.255.255. Sorry, isn't it? Whatever is 0 here will become 255. Whatever is 255 will become 0. Simple. That is what is going to happen. Right. Now, what's the multicasting IP address of OSPF? I told you that all the routing protocols are using multicast IP address, which is what? Class D IP address. Right. Okay. So 224.0.0.5
Pardon, can you
6.
please increase the font size if you don't mind?
Okay. Okay. Or do you want a little bit more?
No, it's fine.
Okay. Now, there are some additional points here which you must understand about the OSPFS. As I earlier mentioned that there is something called as area 0, which is the backbone of the entire network. So there are some things like uh, let's assume that this is one network. So there is a router here, right? So from this network to another network, when it has to go, there should be a router here, and from here it goes to another network. So this particular router is called as area border router, ABR, right? So you can make a note of that, ABR, right? Then we have something called as designated routers, and we have something called as backup designated routers. Now you need not understand about each and everything there. You just have to understand what are these. That's it. Right? Now for and something important if we see here. Okay. Now the commands which are important, which are related to OSPF, on which you will be configuring on the router is like if you want to see who are the neighbors for the OSPF protocol you have configured, show IP OSPF neighbor. That's it. You will be also you can also see the details by show IP OSPF database. So what will a database show you? Database will show you everything which is in the network. So let's assume this is an OSPF configured network. We have a router here also. This router will also know the information about this router, and that will be stored in the OSPF database, right? And obviously the basic command which we learned earlier, show IP protocol. Once you do this, you will get the information like this. And in that you will see for OSPF like this, like O. If it is an inter area, then it will be IA. If it is an external type, then it will be N1, N2, E1. So these are some things which is really complex and will only be seen in a very big organization, right? So these are the basic things and commands related to OSPF. These are the commands which are related to. These are the commands related to our RIP, but they will be same. So this will be same. This also will be same. So everywhere you can use this command. It's not like they are just relevant to that and this. Right. So that's it about routing. Now you tell me if you have got any information or you want something which you didn't understand from the session we have gone through. And I would highly recommend you to go through the online videos for the routing configurations, for checking how the Cisco Packet Tracer and GNS3 works. It's not required that you create a lab and then you start working on it. Not required. You go online, watch a video, understand what that particular person is doing on the in the video. Just make a note of the commands, what extra things they have done, what's the command output, take screenshots of that and try to memorize it, right? So that when you give an answer, there should be something that should be something which is relevant. It shouldn't be like in a layman term. It should be something which is you have done it, something like that. So create an atmosphere like that. Learning is only for just understanding what is what. But in an interview, that is not going to help. In an interview, these things is going to help. That is the reason why I'm bringing few screenshots from here and there and trying to explain, right? So I think we are way past our daily time, but still, I think it would be beneficial for you to go through videos, right? Okay. I don't think any further queries are there. So I think we are good to wind up the session, or do we have any queries?
Yeah, Abhishek. In general, we configure router through putty like that, na? So,
No, no,
uh,
sorry. What was that, Naveen? Can you repeat?
yeah, in general, we configure router through putty. Am I right?
It's a terminal, right? Yeah, okay.
Yeah. Normally, if we go through online, we can see those videos also now. You know the real how they will do, so that we'll have idea in the real case scenario.
Exactly, that's what I'm telling. That's why I'm telling you. See, learning is something which I can teach you here based on the protocols and all. But
Yes,
something which
yes,
you have to see and experience that you have to learn. Now you told me about putty, right? So this is nothing but is just a command line tool, right? Which you are going to use in order to access the routers. Now, one thing in an organization, they only use putty terminals. The reason being that the router will be somewhere in United States and you are sitting in India. How will you log into the router from India? So what
yes, yes,
happens is this router will be connected to the internet, right? Obviously, it will be connected to the internet, and this router will have a interface which will accept SSH connection, secure shell
secure
connection.
shell.
Exactly. Now, when it is accepting connections for the secure shell, what is going to happen is you are going to open your CLI tool. It can be any CLI tool, right? So let me name a few like MobiXP,
PowerShell.
PowerShell, right? Solaris Putty. So there are n number of tools like that to take remote access and configure the router according to what you wanted, what to configure, right? So that is how
Yes.
network admins also do. They need not go to the site locally. They will never go to the site locally. They will ask the network admin there to enable the SSH access so that they can take remote access, right?
Yeah, yeah.
So yeah, that's the reason why I'm telling you, go watch some videos, get to know and get well versed with those videos. Try to understand what he's trying to do there, because there will be a lot of extra things what you will learn there, right?
Understood.
Okay. Any further queries?